Hello, I'm Mr. Royce. This is Calculus BC. Let's get started. The summer packet is due tomorrow. And I'm going to be posting the solutions to the summer packet here so that way if you get stuck, you can look at it. But I realize that some of you might just have some questions on it right now. In fact, one question came up as people were walking in the room, had to do with number 9. And as I understand it, the question had to do with, like, what do they mean by an interval of convergence? Is that what you were referring to? Yeah. So the idea behind an interval of convergence, and I'm not going to actually do the problem for you here, although the solution will be posted before the end of the school day, certainly. But here's the idea. If you have an infinite geometric series, first term plus first term times the common ratio, a1 times r plus a1 times r squared plus dot, dot, dot forever. That's an infinite geometric series. And you probably remember from college algebra. Yeah, I'm sure it came up. I'm sure it came up from pre-calc advanced that provided the absolute value of the common ratio r is less than 1. If that provision is satisfied, then what is the formula for the value of an infinite geometric series? Who recalls? It's a1 over something. 1 minus r is correct. So it's a1 over 1 minus r. So when they ask you for the interval of convergence, they're basically asking you for the values of x. It'll be an interval of x values that cause the absolute value of r to be less than 1. Well, notice that this infinite series is in ellipsis form, but this problem is given in sigma form. So the question is, how do you convert a series from ellipsis form? And that ellipsis form is just referring to that dot, dot, dot. That's the ellipsis. How do you convert it to sigma form? Well, the sigma form for a geometric series is the summation from n equals 0 to infinity of the first term a1 times r to the n. R to the n. Which is a somewhat arbitrary way to write it, because I could have also written it as the summation from n equals 5 to infinity of the first term times r to the n minus 5. I mean, it really doesn't matter what the first value of the index of summation is. It could be 0. Whatever letter is under the sigma is called the index of summation. So notice that's an n minus 0. If it's 5, then you go to n minus 5. Because it makes sense that the first term is going to be a1, because if you put a 5 in for n, r to the 0 is 1, so the first term is a1. Either way, it matches up both of those. However, no matter how you write the first value of the index of summation, you get a1 over 1 minus r. But that is a provisional formula. It is provided that the absolute value of r is less than 1. So just to get you started on this one, I would want to try to get this sigma notation into that form. It's like, where's the a1? Where's the r? And the way I would do that is say, okay, let's look at this. It looks like this could be rewritten as the summation from n equals 0 to infinity of, notice it's an alternating series, alternating, I mean, it's okay, it can alternate positive, negative, negative. But it looks like the first term is 1 times 2x minus 3 all over 4 to the nth power. So I could put a 1 up front. So the 1 matches up with the a1. And the r appears to match up with negative 1 times the quantity 2x minus 3 over 4. So now I know what the common ratio is for this series without even taking the time to write out several of the terms and take any given term divided by the previous term, which is how you could. That's another way you could find the common ratio of this infinite geometric series. So what you're going to have to do in part B is you're going to have to solve the inequality, the absolute value of r right into here, but it's going to be the work you do in part B. The absolute value of r has got to be less than 1 is your starting point. And then your second step would be to replace r with negative 2x plus 3 over 4. That absolute value has to be less than 1, and then go through and solve for x. Your answer will be an interval. It will be called the interval of convergence, the interval of x values that cause the series to converge. So that's what I have to say about 9b, okay? Are there any other questions on the summer packet, things that were confusing to you as you were trying to work this through? Just going to pause the camera until we find out. Okay, we're back. The next question on the summer packet had to do with problem 8. Now, this is a nice opportunity to review graphs of polar curves from pre-calculus. Now, every equation has two graphs, a rectangular graph and a polar graph. Like if I were to look at the rectangular graph of r equals 4 cosine theta, then that would be sinusoidal in shape. It has an amplitude of 4. Cosine starts at max, so it goes max. D mid, D for decreasing mid, min, I mid, max has a period of G. So that's what the rectangular graph would look like. But the polar graph is typically superimposed on the xy plane. And notice that when theta is 0, so just imagine rotating angle 0 on the unit circle, pi over 2, pi, 3 pi over 2, 2 pi, etc. Just going around. And what's r doing? R starts out, I'll be able to show this dynamically by using my rotating tool, make this epic. So we'll go red. So start out with 4. So 4, and by the time we hit pi over 2, the radius is shrunk down to 0. And by the time we hit pi, it's shrunk to negative 4. Well, in the pi direction, negative 4 would mean actually going back this way. So what happens here is a circle is drawn. That circle has a diameter of 4. So if you remember your polar graphing quick sketches from pre-calculus, then you'll say, oh, they want me to find the area of the circle whose diameter is 4. Then you can take it from there. You can just use your geometry area formulas. So it is a circle. Now, if you wanted to argue that it really is a circle, use the fact that x squared plus y squared equals r squared is one of the conversion formulas. And then, let's see, we've got theta equals tan inverse y over x. There's 4 conversion formulas going back and forth from polar to rectangular, rectangular to polar. We know that if you want to go from polar to rectangular, the formulas you would use would be x equals r cosine theta and y equals r sine theta. So you could replace, if I wanted to convert this to x's and y's, check this out. I could replace r, actually, better yet, let's just square both sides of this. Get r squared equals 16 cosine squared theta, because then I can replace r squared with x squared plus y squared. And if cosine theta is x over r, then cosine squared theta would be x squared over r squared. Do you follow that substitution? So now, once again, I would replace r squared. Again, this is not required for this problem, but this is just to confirm my conclusion that the graph is a circle. So, because they didn't say it's a circle, they just called it a curve. So I'm going to replace r squared with x squared plus y squared. So when you multiply both sides by x squared plus y squared, you get x squared plus y squared. Squared equals 16. So that means that x squared plus y squared, 16x squared, equals 4x squared. Yeah, my handwriting was a little messy there, so I didn't notice that that was an x squared. I want to make this a little bit neater so that Maddie will be able to see this, interpret it properly. Taking the time to write this down. Okay. So if x squared plus y squared equals 16x squared, then when you take the square root, ignoring the negative square root, you get x squared plus y squared equals 4x. That's where you'd have to complete the square. X squared minus 4x plus blank plus y squared equals blank. The number that completes the square, take negative 4, cut it in half, is negative 2 squared is 4. So that gives me x minus 2 squared plus y squared equals 4, which is 2 squared. So that basically gives me a circle centered at 2, 0 with a radius of 2. So that's a lot to be said about number 8. So I will post the solutions so that if there's any other questions on the summer packet, hopefully you'll be able to get those answered for yourself when you're comparing those. Then I'm going to have you do an online submission. So try to somehow get your, wait a second. No, you just wrote that out on paper. So to make an online submission, that means, how many of you, just out of curiosity, did the summer packet work on your Surface? How many of you did it on paper? Yes, so if you did on, I'll accept either one. For tomorrow, since I don't want to throw you off and make you go through a big long process of PDF files. If you want to do that, that's fine. I understand. It's easier to do that this year. Video tutorials on how to do that. But for tomorrow, I'll accept it either way. But I'm going to put an online submission for you, for those of you who are prepared to submit a PDF. Okay. Now, I'm prepared to give you paper handouts, but I know that now that we have the surfaces that are high powered, a lot of people are more enthusiastic. I mean, usually with the old surfaces, people were like, just give me paper notes. How many of you have made how many of you are like, I want to do surface work. I just want to do all my work on surface. Note taking, homework, all on the surface. Is there anyone in that category? Okay, and then, so, how many of you are thinking, you know what, I'm fine with doing notes on paper. I'll take your paper notes, Mr. Royce. Is there anyone in that category? Who's like how many of you are like possibly in the I want to take notes on paper category? Tell you what, since I have, well, you know what, I'll ask you, I don't want to keep making paper notes if you're not going to use them and trying to do it in your notes. If you're going to do it paper, but let me raise your hand if you do not want me to give you paper notes today, just to send a clear message that you're working on your surface. You already decided. Raise your hand if you do not want paper notes.
You have the same notes on our surface.
Okay, so what you do is, if you want to check out homework 1.1, 1.3, 1.2, 1.3 notes, these are the notes we'll be starting today. So you might want to download that PDF. And we're starting a unit on limits and introduction to derivatives. We'll just toward the end of next week, probably block day next week. But okay, so you take a look at these notes, and there you can see nice and clean. Oops, that actually shows, you can delete that first page. It doesn't have to be there. But if you the 10 connections between limits and graphs, that's the beginning of the lesson we'll be looking at. And I mean, I have the same handout here. So now that you see that you can easily download it and organize it perhaps, how many of you are thinking that you want to raise your hand down and say, I do not want those paper notes? Raise your hand if you're in the I do not want your paper notes category. So it looks like all I have to do is make 2, depends on what Manny wants, maybe 3 copies of the notes. Okay? No paper notes? No, you don't. Okay, you're good. Okay. All right, so that tells me how many copies to make every day. Good. So So let's take a look at this first lesson. It has to do with connections between limits in graphs. And by the way, the homework that I'm beginning to teach you today will not be due until Friday of this week. This is like essentially a 2-day lesson. So we don't have to finish this 6-page handout today. But the solutions to homework, we're going to call it homework 1.2, will be posted. In fact, if you look online, I have already posted the solutions to the homework. Homework 1.2 solutions. The syllabus, calendar, it's all up there too. So, but for now, what you need to know, summer package due tomorrow, homework 1.2 is due Friday. In case you're wondering what's going on with the solutions, when you look at the solutions, you will see that I took screenshots of the problem and then put the solutions on there. So this is what it should look like. You should be able to, so it's not just the answers. This is detailed solutions, step by step for the whole course. Honestly, I really do think this is one reason that students end up doing so well, is that we don't have to spend all sorts of time struggling through questions on homework during class. So let's take a look at these 10 connections between limits and graphs. And the 10 connections, it's approximately 10, sometimes more, but they're written in template form on the bottom of page 1. So when we look at connections between limits and graphs, and if you're not sure what to do, go back to the bottom of page 1, take a peek. It might be the limit is blank and the graph has an odd vertical asymptote at x equals a number. Let's just jump right into our first example on page 2. Please go to page 2. And let's call this the x-axis and that the y-axis. And so we see that there's a horizontal asymptote at what appears to be hold on a second. Does it appear to you? Yeah, this is where the numbers are. This horizontal axis. Now, what number does that appear to be right there? Do you see a number on your paper? It's hard to read, isn't it? I believe that's a number 2. I'm pretty sure it's a 2. Yep, 5, 10. So we're going to call this the horizontal asymptote y equals 2. And this is the vertical asymptote x equals -4. So in case there's any trouble reading the graph, that's what this graph is supposed to represent. Y equals 2, x equals -4. So the question is, what is the limit as x approaches infinity of f of x? How many of you feel like in pre-calc you understood a lot about what a limit is? Like you studied limits and you feel like you understand. Is there anyone in that category? How many of you feel like you're kind of shaky on limits and you wouldn't be offended if I kind of taught them from scratch? So you wouldn't be offended. Okay, all right. That's good for me to know. Please do not pretend that you understand anything about limits unless you understand them verbally, graphically, algebraically, numerically, using technology, and how they are connected to RW, the real world. Verbally, a limit is an output value of a function. It's like a y value. The limit is a y value. No, it's y's. That vertical axis is not always the y-axis, but so in general it's an output value. That's what it is verbally. So graphically, you'll be looking for the y-coordinate, and that's what we're doing here. the limit as x approaches infinity. So as the input approaches infinity, the output is approaching what? Well, what does it look like the output of the function is approaching, Charlie?
Horizontal asymptote.
Which happens to be what?
The same graph.
So, yeah, so it's 2. Remember, verbally understood, a limit is an output value, an output numeric value. So that means we would say the limit is 2. Okay, but it is connected to some part of the graph. So describe the connection between the limit and the graph. So when you peek back at the bottom of page 1, it's like, what is it about the number 2 and the graph that are connected? Well, it looks as though NVA is non-vertical asymptote. So a horizontal asymptote is just an example of a non-vertical asymptote. So it looks like it's the 4th statement. You would say the limit is 2. Here we go. It's got to be a sentence. The limit is 2. Say, and the graph has. And the graph has could say either a non-vertical asymptote or a horizontal asymptote. A horizontal asymptote at y equals 2. Once you start understanding limits verbally and graphically, algebraically, numerically, technology in the real world, then let the pretending begin. Then you can start pretending that you understand what a limit is. So, no, actually, it won't be pretending anymore because you'll actually understand. Unfortunately, sometimes math students get a narrow, restricted vision of their mathematical understanding. They say, well, I don't like graphs. Graphs are so uncool. I'm just gonna forget the graphs and just do algebra and numbers. Math is just numbers and letters, not words, not pictures. This is an English class. This is math class. What are words doing in here? No, it's words and pictures and numbers and letters. And it's connected to the real world. Here, you try one. Oh, and by the way, we haven't even pronounced this. Half the trouble is, let's put the V in vegan tomorrow. That's vegan, VGA. It's just an acronym, vegan tomorrow. Like some people, it's like, wow, see all the YouTube videos, it'd be so cool to be vegan, but then it's like, I'll be a vegan tomorrow because today I want to just want to go to Outback Steakhouse. When I say go, I'd like all of you to say out loud and in unison, let Maddie hear you at home. I'd like you to say, I'll be a vegan tomorrow, but today I'd like to have some chicken McNuggets. Ready? Go. I'll be a vegan tomorrow, but today I'd like to have some chicken McNuggets. So please don't let yourself off the hook. Don't pretend you understand anything in mathematics unless you understand it verbally, graphically, algebraically, numerically, technology in the real world. Okay, so we're just beginning to develop our understanding here. But to put the V in vegan tomorrow, when I say go, would all of you please say out loud and in unison, the limit as x approaches infinity of f of x is 2. And people struggle with the words. The limit as x approaches. Yes. The limit as x approaches infinity of f of x is 2. Let's try that. Ready? Go. Okay, now hold on. It's the limit as x approaches infinity. And that as x approaches infinity is actually important because what you want to do is visualize a journey. Maybe this is a train taking a journey along the graph, and this journey is as x approaches infinity. So you're asking yourself, What is the y-coordinate of this train approaching as the x-coordinate of the x-coordinate of the train approaches infinity? Just the word as, it's a tiny word, but it helps you visualize movement as x approaches infinity. So try it again. Ready? Go. The limit as x approaches infinity of x is 2. Yeah, which means the output value is approaching 2. Okay? Try the next problem on your own. And if you're not sure what to do, just flip back to page 1 to take a look at the possibilities. Okay, we're back. And the problem is, what is the limit as x approaches -4? That means that the train, in the real world, there might be a particle moving, or let's say it's a train moving along the track. The limit as x approaches -4, from which way? -4 from the left, or -4 from the right? Or are we approaching -4 from the left? It doesn't specify. Whenever the limit is approaching a number, as opposed to infinity, it is implied that this is a two-sided limit. If it said the limit as x approaches -4 with a plus sign in the exponent position, that would mean we're taking the limit as x approaches -4 from the right, in which case the answer would be -infinity or does not exist. If there had been a symbol in the exponent position above the number 4, a minus sign there, then we would be taking the limit as x approaches -4 from the left. See, I'm on the left side of -4. And what would the limit be had there been a minus sign here? Class? Positive infinity or does not exist. Because you and I both know that whenever you're driving along the road and you see that sign, you see these a lot, so it says speed limit infinity, you realize, oh, I guess there's no limit. I guess there is no speed limit if the speed limit is unbounded. So whenever the output value is approaching infinity or approaching -infinity, where did my train go? Oh, there's a train. So now you might be thinking, that's kind of a lame train. You know, don't trains look more like this with smoke coming out? Doesn't that look more like a train? Yes, it does. So here, just imagine the train. So here's a train, the limit as x approaches -4 from the left. The height of the train is approaching infinity. So that's what's happening in the real world. The output is approaching infinity. But it doesn't say from the left or from the right. So the absence of a symbol there, it's called the zeromorph in language studies. Sometimes the absence of a symbol has meaning. What it means when there's neither positive nor negative in the exponent position is that you have to approach from both sides. And if the left-hand limit and the right-hand limit both come out to 7, then the limit is 7. If the left and right-hand limit both come out to -3, that's 7. But if they don't equal each other, then that's another way to say the limit does not exist. So here, we can't say positive infinity or negative infinity. The only legitimate answer to this problem is DNE, which AP graders understand is an acronym for does not exist. So the statement is the limit does not exist. Does not exist, but you're not done. And it's always and the graph, not and it, and the graph. Who can complete it for me? Looked at bottom half of page 1, you can tell me which one to use, and the graph was. The limit does not exist, and the graph. Charlie, I think you found it. Do you know what to say on this one?
That it's odd.
Yeah, it has a word odd in it. Go ahead and say the whole thing.
The graph is an odd vertical asymptote at x equals a.
At x, but you have to pick a value for a. In this case, that value of a is what? And it's actually -4, I believe. It's hard to tell because for some reason this numbers aren't showing up all that well. Sorry about that. But the graph has an odd vertical asymptote at x equals -4. That's pretty good. Do you have any questions on that? Okay, so we hit 2 pages of that. We have to finish the other 4 pages during class tomorrow. But for the next 9 minutes or so of class today, I want to switch gears. And I want to bring your attention to there are 48 to 50 quick graphs that ideally you pick up when you're in pre-calculus. Sometimes I ask you to review those after the first day of class, but instead of doing that, it does say that on the calendar. But instead of doing that, I want to just explore with you a little bit. And if you're, you know what, I'm gonna need some space for this. So on your handout, notice that on page 3 of the handout, there's quite a bit of space on the bottom. We're not going to need the bottom half of the page. So turn to page 3, and we're going to use the bottom half of page 3 to see what you remember from pre-calculus about solving trig equations. So we're going to let theta represent the symbol. Theta is a symbol, variables are symbols, and symbols don't have to represent numbers, so on the AP test they always tell you that it's going to represent the real numbers. Variables represent the real numbers. Represent a real variable. That's what it means. So I'd like you to solve for theta. No notes. Please don't go on the internet. Solve for theta. This equation. What? Right down. Okay. The equation is sine theta equals -1/2. Would you please rack your brain, try to see what you remember from pre-calc about solving the equation sine theta equals -1/2. I'm going to pause the camera, walk around the room, see what you come up with. Okay, we're back. Now, I toured the room. There's some good work there. Nobody had the correct answer, but there was some good work. Now, some people had, like for example, if you had theta equals sine inverse of -1/2, or if you had arc sine of -1/2, that gives you part of the solution. I mean, I do expect you to go further and say that, oh yeah. Keep in mind, remember arc sine? The range of the arc sine function goes from -π/2 to +π/2. So technically 11π/6 is not arc sine of -1/2. Arc sine of -1/2 is -π/6. So that's a nice thing to review. If you had 11π/6, remember 11π/6 is coterminal with -π/6. But just for the sake of reviewing that. Now, the truth is that theta, I'm going to use set notation a lot, is an element of the set. That's an epsilon from the Greek alphabet. Epsilon is an element of the set. A lot of you had this, 7π/6, 11π/6. Now, both of those are solutions of this equation. It's just that there's more. -π/6 is a third solution. Turns out there's an infinite number of solutions. And because, and this is what I believe, I might be wrong, but what I believe is that what is needed for you to understand where all of the solutions are is a commitment to a vegan tomorrow understanding of everything you seek to understand in mathematics, even solving trig equations. So I would like all of you to represent graphically what the solutions are. Would you do me a favor? Would you draw a muck diagram? Muck, M-U-C, mini unit circle diagram. Since nobody had the correct solution, some of you had partial, but you didn't have all. I would like all of you to master drawing muck diagrams because they're fast and they're so visual. They will deepen your understanding of how to solve trig equations. Every muck diagram has a circle. It's not that big of a deal. It's just a small circle. So a rim, I'll even write down the features over here. Contains this axis segment. It'll be either the x-axis or the y-axis. Since it's a sign, I'll segment, part of the y-axis, from -1 to 1 on the y-axis. 4 ticks, 4 tick marks. Those 4 tick marks will be at 0, -1/2. Negative radical 2 over 2 is about -0.71. Negative radical 3 over 2 is about -0.87. So there's 4 tick marks, non-uniformly distributed. Okay, 4 tick marks. And the axis point. So the axis point will be at -1/2. So just put -1/2. A dashed perpendicular, so put a perpendicular dashed line through the axis point. And then 2 rim points. So notice where the dotted line goes through the rim. Put 2 points there. Those are the terminal points of the solutions. So now, last thing is 2 terminal rays. Terminal rays. Terminal rays always originate from the origin. So it's like there's a ray, zap, zap. Here's a graphical representation of every angle from every real number from -infinity to infinity, whose sine is -1/2. So now that we have a picture of it, we can see, oh, it's not only is it 7 pi over 6, but it's every angle coterminal with 7 pi over 6. Not only is it -pi over 6 and 11 pi over 6, but every angle coterminal with 11 pi over 6. So here's what I was looking for, full credit solution. Theta is an element of the set 7 pi over 6 plus all of its coterminals plus 2 pi k, or maybe you use, and I don't care which letter you use, but we have to define it. 7 pi over 6 plus 2 pi k and 11 pi over 6 plus 2 pi k for all k that are elements of the set of integers. Z is the reserved letter in mathematics and set notation for the integers is because the German word for integer begins with the letter Z. Now you might be thinking, well, Mr. Royce, your expectations are too high. Do you really expect us to draw a muck diagram every time we solve a trig equation? Well, first of all, it'll help you really understand what's going on. The answer is yes, I do. Second of all, it doesn't take long. It doesn't take long, because watch this. I mean, it may take a while when you're teaching someone how to do it, but watch this. If I were to do it just in real time, sine theta equals -1/2. What is it? It's 4 ticks, and then suddenly, there it is. There's a picture. It didn't take long. So theta is an element of the set 7 pi over 6 plus 2 pi k, and 11 pi over 6 plus 2 pi k, for all k that are elements of the set of integers. Now it's an upside down A, stands for the English phrase for all. For those of you who are unfamiliar with what looks like intimidating mathematical notation, that's an upside down capital A. K, it's the epsilon again. Epsilon is used a lot in set notation. And the set of integers. When I say just as you're walking out the door, I want you to say, for all k that are elements of the set of integers. Try it. For all. I'll have 2 of these muck diagrams on the homework due Friday. Okay, you are dismissed.
Tommy Reed.